Welcome. You are watching episode 44 of Regional Wrap, recorded on Monday the 11th of April for release on Wednesday the 13th of April. Regional Wrap, providing an insight on the issues affecting regional Australia and giving a voice to regional residents. My name is Bill Bates, and joining me on this episode, the inputs and expertise of IPCC Working Group 1, the science of providing the big picture of climate change, is my guest, Professor Mark Howden. Mark is the Director of the Institute of Climate, Energy and Disaster Solutions at the National University. He is also an Honorary Professor at Melbourne University, Vice Chair of the Intergovernmental Panel on Climate Change, and is the Chair of the Australian Capital Territory Climate Change Council. Mark was on the Federal Advisory Committee for the Third National Climate Assessment, was a member of the Australian National Climate Science Advisory Committee, and contributes to several major national and international science and policy bodies. Mark has worked on climate variability, climate change, innovation, adaptation issues for over 30 years, in partnership with many industry, community and policy groups, both by research and science policy roles. Issues he has addressed include agriculture, food security, natural resources base, ecosystems and diversity, energy, water and urban systems. Mark has over 420 publication credits of different types. He helped develop both the national and international greenhouse inventories that are a fundamental part of the Paris Agreement, and has assessed sustainable ways to reduce emissions. He has been a major contributor to the IPCC since 1991, with roles in the second, third, fourth, and now sixth assessment reports. And he shared in the 2007 Nobel Peace Prize with other IPCC participants, including Al Gore. Welcome, Mark.
G'day, Bill.
Welcome, Mark. Yes, we could just start off. I'll just go through some of the things that we had with Professor Leslie Hughes in regards to the IPCC process, and just refresh them. Basically, the father of climate change is sometimes credited to James Hansen and his testimony at the Congress inquiry in 1998. And 1998, and then the IPCC was born fairly soon after that. And I think the first assessment came out in about 1991, and then we've had the series since then. So would you just like to expand on the process and the beginnings, because you were there?
Yeah.
And actually, I think you were actually involved before the IPCC really got underway in this field.
Indeed, and thanks for that, Bill. So I guess the history of climate change goes back to the 1800s, and so it was first sort of hypothesized back in the 1820s, and it was first measured in the 1850s, and it was first modeled in the 1890s. So strictly the great-great-grandfather of climate change goes back to the 1800s. And of course, James Hansen and others had a big role in the 80s in terms of giving it profile and doing some of the really critical early work on that. And that work has stood the test of time. So when we look at the projections and analysis that they did, they're very robust. Of course, climate change was actually known about before that. And I actually remember when I was a school kid in high school, actually writing an essay about climate change that sort of pins that down into something in the late 70s. And so, it's been known for a long time. The really important thing, I guess, is the critical nature of how we're influencing global processes, climate and other processes, and the rate at which our greenhouse gas emissions are going up are actually become much, much more apparent and much more significant than I think even James Hansen would have indicated back in the 80s. So given those big concerns, it's not surprising that we try to get informed about climate change. And so that's where the IPCC comes in. And there was that confluence, what James Hansen talked about and what many other people across the globe talked about at the time in the science community particularly, was saying we really need to be able to pull the science together so we can inform policymakers about this issue, which to the best of our ability to judge at the time was going to go for many, many decades ahead. And that's been exactly what's happened.
I think one of the things is also nature doesn't play fair, because I'm probably 10 or more years ago. And when I was a school kid, there was actually, we had the stories about global cooling and ice ages and things like that. So nature doesn't seem to play by the rules all the time. So you've got to investigate not only just the impact of carbon dioxide and greenhouse gases, you also have got to look at the vagaries of other inputs. And I suppose this is the thing. You've got so many sampling systems now, from the old sort of weather station records to balloon observations. You've got the old ship records where they used to scoop a bucket of water out of the sea and measure the temperature. And now I think most ships are actually fitted with mechanisms where they automatically take temperatures of water and report it. Then we've moved on, of course, to aircraft observation and special aircraft fitments for high altitude observations. And of course, now we've gone on to satellites. So we have a myriad of inputs. So how do you manage all these myriad of inputs as the science inputs versus just the difference of just specifically looking at greenhouse gases?
Yeah, there's a lot in that, Bill, to unpack. So for starters, I think in a sense, nature actually does play fair. We sort of just changed the rules, and that's sort of what's happening there. And you're right. If you go back sort of into that sort of period around the 70s and 80s, there was discussion about global cooling, and that's because when we look at the ups and downs of temperature with ice ages, the current period, the warm period that we've been in for the last about 15,000 years, it does show a long-term cooling. You know, like eventually we would have headed back into an ice age if we hadn't started mucking around with the climate. And so there was, good evidence that would happen. And secondly, there was concerns about the possibility of a nuclear winter. So, because of Cold War, atomic bombs going off, lots and lots of dust in the atmosphere, and that would have cooled the Earth. It would have actually caused quite an extended period of cold and weather and much lower solar radiation, which would have driven down crop growth and hence really significant impacts on food security and many other things. And so that nuclear winter was the particular driver of those discussions about global cooling. And so we need to separate out some of those issues and put them in their correct context. In terms of what you're saying is that people have been taking measurements on climate for a long, long time, and over a period of time, in many ways, those measurements have expanded. So all of those measurement types that you mentioned, plus we've got lots of satellites, and we find really smart ways of measuring historical temperature variations and historical rainfall variations, and lots of huge amounts of data there. And there are global programs to bring that all together. And so we've got the Global Observing System program, which has got largely every country on Earth signed up to it, but with massive amounts of data. All of those types of data and many more are pulled together on a almost minute by minute basis by those observing programs. And they're not just to deal with climate change. Much of that is actually to allow us to run our weather models that give us the weather forecasts for today and for next week. And And so we're collecting all of that information on sea surface temperatures and on ocean currents and on atmospheric humidity and all sorts of things on that basis, that we can use that information right now for good purpose, and we can actually use it for climate change analysis as well.
I think the other thing is too, there's always new innovations in sort of detection systems and that. I was reading just recently, they're looking at to help standardize measurements and that on a lot of different factors. They're looking at actually using moonlight as a standard to do measurements. So there's a lot of different innovations. And of course, with the satellites, the new satellites get old, new ones go up. And of course, then comes a bit of an issue in regards to the performance of the old satellite versus the new satellites, and then sort of getting the adjustments to make sure there's continuity in the actual measurements.
Yeah, and that's right. And so even within the life of a satellite, sometimes you get sensor degradation. So the sensors themselves get affected by time and exposure in space. But you also get orbital degradation. So the orbit changes slightly. So over time, the satellites come closer and closer to Earth because of friction with the very sparse sort of atmosphere way out into space. And so sometimes the orientation of those can change. And so you do need to have good, continuous analysis and assessment or calibration of those satellites to make sure that the information you're getting is consistent. But that's now pretty standard stuff. Like back in the 90s, there was discussion about how those continuity issues and calibration issues were affecting the global record. But that was basically sorted out in the late 90s. And, people who raise that as a problem in terms of assessing what's going on in climate change are probably about 2 decades out of time.
The Working Group 1 report, the current one is, I think, 900, about more than 300,000, 3,964 pages or something. It's huge. So how does the controller of that actually manage all the inputs? I mean, I think it's probably helpful now. There's been 5 done before, but I can't imagine the effort or the requirement and the coordination required to get some of those initial ones together.
Yeah, well, if you add up the Working Group 1 report on climate science, the Working Group 2 report on climate impacts and adaptation responses, and the Working Group 3 report on emission reductions, roughly there's about 10,000 pages, and they're densely packed pages. They're not, big type and widely spaced. This is really small type.
I actually got a sample of it here.
Yeah, and it's dense. And so that you're quite right, Bill. There's a huge amount of information which is summarised in those reports, and so if you think of it, on most of those pages you'll have probably some dozens of references to separate studies. So there'd be a study, say, ocean temperatures off Queensland, for example, and that study itself will reference possibly megabytes or gigabytes of data about how the oceans off Queensland are varying under different circumstances, say El Nino sort of things. So you have this massive amount of data which gets summarised in that paper, which gets summarised in the chapter of the IPCC, which that gets summarised in the executive summary of that chapter, and that gets summarised in the summary for policymakers of that working group report. So what you have is you've got a huge amount of scientific research happening, which through various steps in this process, this IPCC process, gets boiled down to its absolute core. The core messages that are important for policymakers, and that takes a huge number of authors to do, and it takes in many review editors and reviewers to actually make sure that what's being said there is exactly what the science says.
So AR6 in its entirety would be bigger than the Australian Tax Acts.
Oh, well, probably would be, but probably easier to interpret.
Actually, I'll just flick a screen up of the actual current state of the one of the pages from the AR6 Working Group 1 report. Where are we? PDF. That's it there. Are you still somewhat disappointed that it's not in its final sort of printed version or printed state instead of what we see now on the internet? And will we see sort of updating? Because I started reading some of it and then I really had to really go back to AR5 to look at the picture and their explanation a little bit in some of the information. Are we going to see the final print type edition in the foreseeable future before COP27?
Yeah, look, I'm not sure on the publication dates, but certainly the intention is to bring it out as quickly as possible. In this particular IPCC cycle, there was a bit of a hiccup in terms of the publication process, and so we're working to resolve that. But all of the reports are available, off the web as a PDF format, and that's really important that it's accessible to anyone who has an internet connection. So it's a very much democratized the outputs of the IPCC, and so you can actually go into the 6th assessment report, and if it refers to the 5th assessment report, you can go and download that as well, and so you can check for yourself, what things have changed and what people were saying back 7 years ago.
I think maybe because of COVID, is this the first time that the summary, Working Group 1, Working Group 2 and Working Group 3 is come out, months apart?
Excuse me. Normally they'd be more separated, so you'd have several months between the release of each of those. But because of COVID, we had to contract the timing of that, and so we had this situation where we were releasing the Working Group 2 report, and 1 month, and then a month and a little bit later we were releasing the Working Group 3 report on emission reductions, and that's way too close for comfort, because people get exhausted by the process, and not just the scientists but also the government people who are engaged in that approval process. So that approval process in each case went for 2 weeks, at all hours of the day, and it was incredibly demanding, and so people get shattered by that. It's absolutely exhausting process, and so normally we'd space that out, but because of COVID we simply couldn't.
I also think maybe you do need 7 years between reports to get over the last one.
Well, yeah, I mean, in the sense you don't want them too close together, because it wears out the science community and the policy community who deal with this. But you don't want them too far apart either. And so what we've evolved into is this sort of 5 to 7 year sort of cycle, to sort of manage that sort of factor. Increasingly, what we're seeing is special reports like the 1.5 degrees report, or the land report, or the ocean report, which are smaller reports, and they come in and, in a sense, fill the spaces between the really big reports, the 3,000-page ones.
Yeah, the other thing is with who decides what the inputs are going to be into the reports, because I think there might be about 13 different chapters in Working Group 1's report. Of course, everything starts off with an introduction, and then there's different headers for each chapter. Where has that been sort of collated and kept for us a long time, or has anything there changed much other than the general input to each chapter? Yeah.
So it's a good question. So pretty much everything about IPCC is done incredibly transparently. And so for example, every comment made by a reviewer of the IPCC is recorded and it's available publicly. And it not only shows the comment and the part of the text that it relates to, but it shows the author's response. And then it shows the review editor's response to ensure that the authors have adequately responded to the comment that was made in the first place. And all of that is available. In terms of what the report's covered, that's what we call the scoping process. So at the start of each cycle and each report, we have a big meeting of scientists and policy people to work out what the scope is of each of the working group reports. And so that's the chapters that you see in front of you, the 13 chapters from working group 1. And so you'll typically what you'll get is a set of governments who actually very broadly identify the things that they're interested in. Then you'll have a meeting of scientists who take that information and guidance from the chair of the IPCC process to scope out the chapters of or the content of the next working group report. And then that goes back to governments for discussion and approval. So what we end up is a scope of each of the working groups and each of the chapters. So what each chapter will broadly deal with, which is identified both by the science community as being important and answerable, but also identified by the policy community, the governments of the world, as being what they want to hear about.
The contributors and authors, the reviewers, and that it amounts up to, I reckon, more than 1,000 people looking at the list. How is the process in regards to deciding who goes into what position? How's the higher up part of the panel decided? I gather there's for authors and contributors, there's sort of invitations and consideration from what I've just sort of gleaned. And then you also, if you go back and you check the records of contributors and authors for the different IPC, there are a number of people who are there on a number of occasions. And there's, of course, people who only did one or two reports.
Yeah. So when we look at the process of who's involved, there's different processes for people in different parts of the IPCC. So at the start, what we actually have is an election process. So there's the governments of the world get together at an IPCC plenary and they elect the chair and the vice chairs and the co-chairs of the whole IPCC process. So those are, you've got nominations, say, for the chair position, and then the governments will vote on that, who they want to be chair. And so for all of those, what we call the IPCC Bureau, and I'm a member of that, we were voted in by the governments of the world. And so, just as it's a pretty straightforward voting process. Then, in terms of selecting the authors for the chapters, that will then go through a nomination process. So we put out a request for nominations for the convening lead authors and the lead authors and the review editor roles. And people will apply based on their interest and their experience. And so they'll send in CVs and that sort of information. And then the Bureau members select out of that author pool the authors who are going to engage on each of the chapters, and then in the writing of a chapter, there's additional authors who are brought in just to write, say, a paragraph of material, and they're called contributing authors, and they're identified by the author team and they're approved by the Bureau. And so what we have is different sort of roles there across the authors. And then you've also got what's called the technical support unit. So for each of the 3 working groups, the co-chairs have usually come with a bucket of money from their government. So for example, previous in this round for the working group 2, there was the governments of Germany and South Africa were the co-chairs. So the co-chairs were from Germany and South Africa, and each of those governments contributed resources to run the technical support unit. And the technical support unit are professional staff, people who deal with science policy and science communication and IT and those sorts of things. So different parts of the IPCC entity have different processes for being engaged.
With the past reports, there's a wealth of information there, and it's all catalogued, understood. But then for the next issue of the report, obviously you've got to have additions to that current information, like updates on the data you already have. And then you also would have new science or new papers coming in that have an impact, or basically get a Guernsey for inclusion. Who decides what new information actually gets into the chapters, and how do they sort of define the importance of these new bits of information? Because I have seen a section of it where it says that there's an improvement on report 5, and this is the information, and this is how we're more assured of the information. So there's little statements in the actual report itself referring that there's been additional information and it improves on the basically the value of the previous report.
Yeah, yeah, and that's right, Bill. So typically, the IPCC in any given cycle builds on what's before there, and there's a long history of that within science. Going back to Isaac Newton. If I see far, it's because I stand on the shoulders of giants. It's recognizing that what has come before is really important in terms of taking the next step. And so there's a long history of why this is actually done in science in this way. So typically each chapter will identify what the key messages of the 5th assessment report were for that chapter. So for example, if it's a chapter on cyclones or extreme events, it will say, this is what the 5th assessment report said about extreme events. And then it will go on to say, this is our new and enhanced understanding. So this is the totality of what we know at this point in time. So rather than repeat in its entirety what was in the previous reports, it just references them and then builds on them. And so in that way, it can focus on the particularities of what knowledge has improved and what data has improved, etc., since the previous report was published. And the choice of how to do that is done by the author teams. So the author teams are given a mandate and a responsibility to actually do exactly that. And so what we do is we bring together the best experts across the world who understand that topic and understand, say, for example, the interactions between different components, the interactions between the oceans and the atmosphere, and how cyclones are formed, and the damage function of winds, and how we record different wind speeds at different times of history. So we've had different techniques of doing that. So you have experts who have a really comprehensive understanding of that whole topic, so they can summarize the advances in knowledge.
In regards to those things like cyclones and historical temperature measurements, floods and all those sort of things, they're not causation, they're indications or impacts from climate change. In the report, what sections do you think are the most important? Because the most interesting one I found was in regards to the radiative retention in the atmosphere, and then also some of the stuff on the climate modelling.
Yeah, look, I think the idea is for every section to actually have something important to say, and so it's sort of hard to pick out winners in that sense. But for me, the sort of the core messages, which is there's definitive evidence that humans are causing the climate changes that we're observing, is a really important statement. So it's no longer a probability statement. There's a 95% chance of this being caused by humans. What it says is humans are unequivocally the cause of the changes that we're observing. And then it divides that down, and it talks about this is how much is due to carbon dioxide, and this is how much is due to methane, and this is how air pollution has provided some cooling influences in various parts of the world. So those are key messages for me. The other key messages, I think, are about the trajectories of greenhouse gas emissions and how they will influence global temperatures out into the future. And so what happens if we go on a high emissions trajectory versus a low emissions trajectory, and also what's happening in terms of extreme events and what we can anticipate future in terms of extreme events. So those are the things like, heat waves and floods and cyclones.
And that really leads on to Working Group 2's work in regards to determining the impact. And then 3 is basically mitigation, what we're going to do to mitigate the whole situation. But if I could just get onto the topic in regards to basically input data versus modelling data, how do the two intermesh, and which one sort of is more guiding than the other, or are they both equal?
Yeah, so it's an interesting one. So when we talk about the input data, it's like measurements of temperature, of the oceans and the atmosphere or the land, or it's pressure systems and the movements, or it might be cyclone tracks and strength and those sorts of things. So automatically, if you think of it like that, is that the data always refers to the past, whereas the modelling can refer to both the past and the future. So we can run models over historical periods. It may be over millions of years to look at evolution of climate over that sort of time scale, or it may be over very short periods of time in the past, just looking at perhaps evolution of the last El Nino event or something like that, or it may be out into the future, again for varying time limits or time frames. And what we do is that essentially a model is an encapsulation of the data that we have and our understanding of the processes that drive that data. So in the case, for example, of atmospheric dynamics, we look at the processes of energy and mass transfer in the atmosphere. So what happens to masses of air and the energy, the temperature of that air as it moves around the globe and up and down in the atmosphere. And so what we try to do is we try to understand the model is a statement, our best understanding of our statement of the processes that are driving our climate and our ocean currents and various other things. So the data and the models are intimately linked, and together I think they provide us with a much stronger understanding of what's changing and what may change in the future than if you relied on just one or the other, because you'd be hamstrung if you did.
Of course, the whole conversation in regards to climate change really has run itself around into a real tight circle over greenhouse gases. And that's the focus of politicians, the people who promote renewables, and the general public who are engaged in this conversation. Is that really the focus that we really need to concentrate on, and just look at those issues in regards to the amount of CO2 we've put in, the greenhouse potential of each of those gases, and its ongoing impact as those numbers increase for carbon dioxide, methane, nitrous oxide to a small degree?
So I guess I should address you. So you mentioned there, or you made a comment that the climate change discussion has sort of tied itself in knots or gone in circles. I actually think that's quite disputable. So if you actually look at the science of climate change, it's really, really rock solid, and it's rock solid from the very start of the process to the end of the process. So understanding that all of the different aspects of it. That's not to say that there's not more to understand, but we have a very, very strong understanding of what's going on. Secondly, the public gets this. Is that if people are saying, oh, you know, that there's a lot of uncertainty and the public doesn't understand, well, actually the public does understand. And so repeated Lowy Institute polls run every year shows that 90%, that's 90% of Australians want more action on climate change. You know, Australians understand that climate change is not good for Australia. They've felt the very start of climate change and they don't like it. They understand what's going on in terms of greenhouse gas emissions in some broad context, maybe not all the details, and they want change. They actually want action on this. So what I think we're doing is we're seeing a disparity between the public understanding and interest for more action and what the politics and policy is actually delivering. And if you actually think about that, what's the hold up there is actually entirely about the politics around a couple of sources of greenhouse gases, and that's particularly coal and to a lesser extent gas. And because Australia has so much economic reliance on those particular products, that some people are concerned that if we reduce our production of coal and gas, that we will suffer economically. And that's a legitimate concern. I'm not saying that people shouldn't be concerned or not. But recognising it as a concern, we should just then start to take steps to minimise the impacts of changes in those industries, what that have on Australian economy. And that's essentially the public debate, which we'll see, you know, coming out in this election cycle, you know, the election that's forthcoming. And I think in many ways, it's again a difference between perhaps looking backwards, you know, this is the industries that we used to have, and this is what brought us prosperity in the past, and looking forwards, which is what are the industries that are going to bring us prosperity in the future? And I think they're very different.
What I was referring to there is the focus is really on carbon emissions, and in regards to what's come out of climate change is the focus on carbon emissions, their impact, and then what we've got to do to actually reduce them. And that seems to be the key focus. So therefore, in the science of the climate change, I think the greenhouse gas discussion is the most poignant.
Yeah. So if you want to focus on the greenhouse gases, so carbon dioxide is the single biggest one. But methane is actually surprisingly large in terms of its contribution to warming to date, and nitrous oxide relatively minor. And then there's lots of pluses and minuses associated with, you know, air pollution and black carbon and various other things. One of the big messages that came out in the Working Group 1 report was just how significant the air pollution that we're producing through, say, factories and sulfate particles is in terms of cooling the world. So when we have a dirty industry, for example, and it produces things like sulfur dioxide, those particulates are very reflective of sunlight. So when they're in the atmosphere, they reflect the sunlight, so the sunlight never gets to the ground and it doesn't warm the earth, so it goes back out into space. And that has effectively cooled the Earth by something like 0.3 or maybe even 0.4 degrees. So in the absence of that air pollution, global warming probably would have been around 1.5 degrees instead of the 1.1 to 1.2 that we've observed. And so once we start cleaning up that air pollution, and of course it's in the interests of countries like China and India to clean up that air pollution because it's killing millions of their citizens a year, that what we'll actually see is to some extent that suppressed warming start to emerge. And so when we start to think about these things, we need to understand the sort of complexities of what's going on, and that cleaning up air pollution actually may make climate change worse, at least temporarily.
Well, we certainly don't want to go back to the old days of heavy industry when they were putting out a lot of carbon particulate matter and turning into smog and causing all those sort of problems. That's not an option. But just going on to the radiative value of the different greenhouse gases, and the and the carbon emissions of today. I'll just flash up a couple of screens if it's okay.
Sure.
Basically, here we've got the, and a lot of people sort of don't quite get the RPC 4.5, 6 and all those sort of things. A lot of people relate it to temperature, but it's actually the additional radiative forcing in watts per square metre across the globe as a result of increased emissions. Is that the way people need to look at these scenarios?
Yeah. So if you think of climate change like blankets in the atmosphere, so when you put a blanket or a doona on your bed, what it does is it keeps some of your body heat in against your body rather than it escaping to the rest of the room and then outside the house. And that's what happens with climate change, is that greenhouse gases in the atmosphere, they re-radiate some of the heat that would have otherwise escaped out into space, and they redirect that back towards the Earth. So it radiates in all directions and some comes back to the Earth. So if you think of greenhouse gases like blankets in the atmosphere, so the more blankets we put in the atmosphere, the more heat is kept against the Earth and the warmer the Earth becomes. So that RCP, the radiative forcing, is simply the amount of heat that's kept in by those blankets. So you've showed up, RCP 1.9, which is on the low end of the spectrum, the very low, an RCP 4.5, etc. So essentially think of them like blankets. And so the higher the number, the more heat is trapped against the Earth. And so the idea with those sorts of analyses is that it allowed the climate models to actually be run separate from the underlying socioeconomic analyses. So if it says, here's a model which has lots of blankets, lots of warming potential, but it doesn't specify what constitutes that. So is that because we burnt huge amounts of coal, or is that because we closed down coal but it burnt huge amounts of gas? So it actually takes you away from those socioeconomic decisions and just says, here in terms of the science is the consequence in terms of radiative forcing, which then allows the climate modelers to analyze, well, what does that mean in terms of, say, rainfall or changes in cyclones or changes in heat wave events and things like that. And so that's the idea behind the RCPs.
I'll just show up some of those scenarios. So on here we have a couple of different scenarios in regards to the degree of additional, what it is the additional degree of forcing that would be added as a result of these scenarios. So when they have 8.5, that's actually referring to the number of watts per square meter retained in the blanket, as you might say. And for different other scenarios, it's like 6. It's 6 watts per square meter. And so sometimes people get a little bit confused in regards to those scenarios with watts versus what the new temperature or increase in temperature is going to be.
Well, that's right. So if you think of those in the blanket analogy, if you put 8.5 blankets on top of you in bed, you're going to get extremely hot, and you're not going to have a good night's sleep. If you got 1.5 blankets on your bed, you're probably okay, but you probably, on a summer's night, you might want only half a blanket, and so that's right, and so that's the watts per square meter. So if you actually think about watts per square meter, if you had your old incandescent light, say if you had a 60-watt light sitting in your ceiling, if you put your hand against that, you'd burn your hand. Okay, so 60 watts is actually quite a lot of energy, and And so when we're talking 8 watts per square meter averaged across the globe, across the year, that's actually a lot of extra energy that's coming back to the Earth. And so that's the amount of energy. But then, as you say, Bill, you've got to then translate that to, well, what does that mean in terms of things which we're more concerned about? What does that mean in terms of, air temperature or ocean temperature or amount of rainfall that we get or intensity of rainfall? And so that's the next step in the climate models. You go from those scenarios of energy return, the radiative forcing, to what that means in terms of key climate variables.
And the other thing is too, those figures are based on a sort of baseline. And I think the baseline is basically pre-industrialization, because we had blankets on before we started all this. We already had a nice doona, keeping the Earth at a set temperature. And then, of course, the science has shown that as we've increased these greenhouse gases, that the number of blankets thrown on has increased slightly. And if we don't sort of arrest this situation, the number of blankets we've got to throw on, since I think the baseline is still 1750, that's when you'd say everything was zero, that's the baseline. And between then and now, we've probably had I think the general figure is somewhere about 2.6 watts per square meter increase on that baseline. And so all those scenarios are basically affected off that baseline. Is that sort of right, correct?
That's right. And so we use pre-industrial, or our best estimate of pre-industrial is the baseline. And so we work from there. And so with the observed increases in energy coming back to the Earth, we've then observed temperature increases. So on a decadal basis, we're now about 1.1 degrees above pre-industrial levels, and recent years, the trend line actually takes us to about 1.2 degrees above pre-industrial levels. So we're going up quite fast, just as indicated by that difference between the 10-year average versus the running average, the trend line. And so those changes are really significant. If you think about that, the temperature of the world going back, say, to our last ice age, the temperature in our last ice age was on average across the globe about 5 degrees colder than our historical temperatures. And so 5 degrees is an ice age, obviously 5 degrees colder. So when we're talking about 1.1 degrees or 1.2 degrees warmer, which is where we currently are, it's almost like a quarter of an ice age worth of temperature, but obviously warming, not cooling. And we know that ice ages really, really changed the face of the world. And so in ice ages, on average, there's a lot less rainfall. So we're a lot drier, more arid. We had huge amounts of ice over, parts of North America and Europe, so massive amounts of ice sitting across big parts of the world. And our oceans were 120 meters below where they are now. That's 120 meters, which is massive. So Australia was a much, much bigger continent because we had massive shelves, our shelf across the, outside the coastline exposed because of the massively lower sea level rise. That's why people could walk from the mainland to Tasmania in the last ice age, because the sea level was that much lower. So what sound like small numbers, 5 degrees, fundamentally changes the face of the world. And so the sort of scenarios we're going into, 2, 3, maybe 4 degrees, really, we can't expect them to do anything except change the face of the world. So they're really big. They might sound small, but they're actually really, really big numbers.
I've been chastised, and you might even get chastised by some geologists in referring to ice ages and that, because in geology terms, we are in a current ice age, and their definition of an ice age is any period when there's permanent ice in the northern hemisphere and the southern hemisphere. And what we actually are in is an interglacial period, and what we flow back into is glacial periods within that ice age, which has now been extended by about has been going on for about 2 million years. So just be wary of talking to any geologists, because they're pretty keen to correct people on ice ages versus interglacial periods and things like that.
Yeah, I mean, you're right, and I should have said interglacials versus glacial periods, but I suspect most of your readers wouldn't be across that, or listeners, and so it's important to communicate in terms that people understand. Yeah.
I think that's probably one of the little problems with what we call the little ice age, where we should have really called it the little interglacial or something like that, where we've got sort of stuck in this thought that
it was a localized. It was a localized cooling, Bill. It was a localized cooling. It can't be called an ice age, and so people get confused. That was a very local thing.
Yeah, well, that's what I'm saying. There's a lot of these sort of common known things out there that sort of are misrepresented, but they catch on because it's quite simple. Little ice ages are quite a simple term to sort of people to take in and then repeat, sort of thing. So I think there's a lot of those problems with this type of conversation, that there's a lot of different snippets out there that people take on without being across it a bit more broadly.
Oh, I mean, there is all of that, and but at the same time, I think you'd need to communicate with people in terms that they understand, and I think people do understand the sort of concept of an ice age being a cold period relative to where we are now, and that's clearly the case here. But in a geological sense, we can use lots of different language, and I could use lots of technical language associated with the climate as well, but that's not the point of what we're trying to do here.
No, well, but I mean, that's the thing. There is a lot of things thrown out there at people, and they do tend to grab simple hooks, which is a problem in any sort of type of conversation.
Yeah. Okay. Keep going, Bill.
I will. These are the sort of models in scenarios for the different scenarios, and we see a lot of core focus, and then there's obviously different models in those different fields. So how many models how many model runs are sort of done between each report?
There'd be thousands of model runs like that. And so those curves you showed up were essentially from the sort of previous IPCC reports, and they've been updated in the Working Group 1 report, which was released in August. And the basic story is fairly consistent with what you showed up, though. And so what we see there is essentially a summary of many different model runs, which will have different emission trajectories, and not just greenhouse gas emissions, but say air pollutant trajectories as well. And then they'll run them through different climate models, which will give different, say, temperature results and changes in rainfall and similar things. And so by exploring all of those combinations of different scenarios of economic development and different climate models, then they're summarized down into key messages in a key sort of scenarios, and those are the ones that you showed up there. So they're the bold lines, whereas all the little fine lines are the individual scenarios with different variations of some sort or another there. And the message then comes out pretty clearly that if we keep on emitting at high rates, so continue to increase our greenhouse gas emissions, which is what we're doing at the moment, then that gives you a feel for where we end up in terms of temperature change. And whereas if we go on a very significant emission reduction pathways, it gives you a feel for where we end up in that case. And so it's just a way of stepping forward from specific actions to specific consequences, but it's also a way of stepping back from specific consequences back to the actions that are needed to either get to that point or to avoid that particular scenario. And so those scenarios, that approach works both ways.
Just before COP26, Christine Lagarde, who was the managing director of the International Monetary Fund, and she's now the president of the European Central Bank, and who's been quite forward and has had a prominent discussions and focus on climate change, and she's taken that into the role she's played, and now with the European Central Bank is basically putting climate policy into their lending policies and things like that. Before COP27, I vaguely remember, and I can't find the reference for this, but she was inferring that the work of Working Group 1 has been done. We know the science, but now we've got to move on to what we've got to do. Do you think she's not completely right there? There's still a lot of work for Working Group 1 to do and continue to do?
Yeah, look, I think as you go through the steps, I guess, of understanding how a disruptor then impacts on our societies. One of the first things you do is you identify what the problem is, and what all the drivers are, and then you go on to identify some of the solutions, both the responses to the changes, but also how to avoid the worst case scenarios. And that's exactly what we're doing with climate change. Is that we've had decades of analysis of the climate systems and understanding the problems there, and what sort of future we might end up with different scenarios of greenhouse gas emissions. When we're moving now, I think, increasingly into the space of looking at the climate impacts. So how is climate change impacting, say, on food security and what we can do about it. And also increasingly on the mitigation side of things, so the emission reductions, moving the energy transition, moving away from fossil fuels. And that's a pretty standard, in my view, a standard sort of process of how you go through the inquiry, as you go from the start towards the finish. So if you follow through that, is that it would be understandable and normal for the relative importance of Working Group 1 to decrease versus that's the climate science, versus the impacts, adaptation and mitigation. But I think there is still important information that we still need to understand about climate science. So relatively against the climate impacts and emission reduction side of things, the climate science perhaps may need to sort of decrease. But in absolute terms, we still need to invest in it. We don't know everything about our climate systems. We don't know how, for example, cyclones are going to evolve out into the future. We don't know fully how El Nino is going to evolve out into the future. And they're things which impact heavily on your listeners.
Yeah, well, the regions are the ones who are going to suffer first, because, big cities and that are basically insulated through their infrastructure and those sort of things, whereas and also how they earn their livelihoods, whereas in regional areas, we've got agriculture and all those sort of critical things, fishing. So they're the things that where the impact happens, it actually affects people's livelihoods and way of life fairly quickly. So we have a lot invested in this to make sure it's done right.
Absolutely, and that's why I've worked on climate variability and climate change in agriculture for a long time, because it's heavily impacted by climate. We know that. We know that. Ever since people first came to this continent 60,000 years ago, is that there's a very strong influence of climate on what goes on, and it's evident today in terms of agriculture or tourism is affected by climate. Extreme events impact on our regional economies massively, impact on people, and so we know we're highly sensitized to climate. It impacts on us heavily, and so it follows that any climate change will also have impacts of some sort or another. So Having said that, it's not a foregone conclusion that all climate change impacts are negative. But as it turns out, in Australia, most of them are. There's not too many good news stories about climate change in Australia.
I suppose that's where we've got to move into sort of working group 2, working group 3's work to deal with this. I had Professor Richard Eckhart on last year talking about soil carbon and impacts on agriculture. That was very interesting. I'll be having Professor Brendan Mackey on in a couple of weeks to talk about working groups 2 work. In working group 3, do you think industry has already moved into a lot of the ideas or concepts that working group 3 is doing? Like we've got renewable energies running fairly, with a lot of interest in them. We're talking about hydrogen hubs and a lot of other work. So has industry and the public got ahead a little bit of which is probably necessary than what working group 3 is sort of talking about?
Yeah, so the role of an IPCC is simply to bring together our existing knowledge. It's and that may be knowledge about the past, or it may be assessments of future change. But in many cases, I think if you look back on this, is that the scientists were way ahead of the policymakers and politicians, and well ahead of the public as well. And I think that's the case for this report. What it shows is that this is the Working Group 3 emission reduction report. What it shows is that there's large-scale movements in some countries to reduce greenhouse gas emissions, energy transition, moving to electric vehicles, those sorts of things. But in most countries, the majority of countries, we don't see that trend towards reducing greenhouse gas emissions. So it's, only about 18 out of 200 countries have a long-term sustained emission reduction. So there's a lot of room to move on that. Increasingly, the forward-looking businesses, particularly big business across the globe, is taking climate change into account. That's both the emission reduction side of it and the climate adaptation, because businesses see how climate changes are impacting on supply chains and impacting on profitability and risk. And so if you look at the sort of standard business assessment, the Task Force for Climate Related Financial Disclosure, that assessment deals with the climate disruption and adaptation responses just as much as it does with the emission reduction side of it. And increasingly you see the banks requiring assessment of climate change risk, the insurance companies assessing that, the central banks are moving towards this, and all the big investors, BlackRock and Vanguard and others are all requiring climate change risk analyses of different types. And so big business has moved on this very substantially, and not because they're Boy Scouts and out of the goodness of their hearts, but because this is good business practice. It's just good to actually understand your risk profiles and do something about it. The big gap, I think, is increasingly medium to small businesses, where they don't necessarily have the capacity to do the analyses and to put in place the investment that allows them to move on to a lower emissions trajectory, or to take into account climate change, do the risk analyses themselves. And so I think what we'll see gradually is that will filter through, the different levels of business, because it will be increasingly required by regulators and by the investors communities, as well as being supported by policy, or hopefully supported by policy.
I don't want to get too much into follow-up interviews for the other groups, but do you think there's also a bit of a role to play in regards to making sure some of the enthusiasm for some of these projects don't lead us off into a path that we might regret financially? And then scientifically, you also worry. I mean, I worry when I hear about geothermal type solutions to reducing carbon, or the role of sunlight by putting aerosols in the atmosphere and things like that. Is there a role for IPC to sort of keep people on a bit of a rein rather than going off on, very expensive tangents or even dangerous tangents in the future, because I see some of those things like ideas to put these big facilities at sea to spray seawater up into the atmosphere, like it's scary. No, that worries me in regards to when water evaporates, it's free of salt. But if we're actually spraying salt aerosols into the atmosphere, I don't know what the impact of that is. So is there a role for the IPCC to sort of control those sort of things, or at least mentor them?
Yeah. So the IPCC is purely an advisory entity. So it's not policy prescriptive. It doesn't tell governments you should do this or should do that or shouldn't do this. So simply what it does is it tells this is what the science says. If you do this, then these are the consequences to the best of our ability to judge. So in terms of any of the projects that you're talking about, the salt spraying type 1 or, going renewables, that sort of thing, like any of those things should be assessed on the same basis. Does it make financial sense? Does it make environmental sense? Are all of the social and cultural factors taken into account, and does it end up with us being better off overall? All of that sort of stuff should happen with those projects like it should happen with any project. We don't want to be throwing money around willy-nilly. We want to spend our money well. We need quality expenditure of public monies particularly. And so I think the thing that's coming in here, though, is that climate change, rather than being ignored in the assessment process for projects, is increasingly becoming much more central to that. And so we need to have good information to make informed decisions. That's, fundamental, good business practice and good policy practice. And the science community is here to help with provision of that information. And that's what the IPCC is doing, amongst other things. So I think really important to start, sort of mainstreaming climate change. So we don't see this as exceptional. It's actually just normal part of good decision making. And I think that will help when we see it like that. And we need to recognize that when we look at the bigger picture of economic costs versus benefits, the worst thing we can do by far is actually just keep on doing what we're doing at the moment. Like our current emissions trajectories, increasing greenhouse gas emissions, leads us to a really problematic set of circumstances economically, as well as in terms of health of people, etc. Climate change action is much, much less costly than climate change inaction. That's the summary of all of the economic analyses that I've seen. So it's actually economically sensible to take climate change seriously. Now, in terms of the big geoengineering things, putting particulates in the atmosphere, mirrors in space, all that sort of stuff, highly problematic, because all of those things have big systemic changes. If you put particulates in the atmosphere, which we could do to reflect sunlight, sure, it would keep the world a bit cooler, but it wouldn't stop our oceans from acidifying if we still kept on pumping out greenhouse gases. And if you have less sunlight intercepting on the Earth, our crop productivity would go down proportionately. Our grazing systems productivity would go down. Our ocean productivity would go down. Are those the things that we want in a world which has difficulty feeding itself right now? So no. So we need to approach any of those things with a really well-informed base.
It's just worrying sometimes that these ideas get aired and run with the media, and then you even have quite high-profile people talking on it. It's sort of it's not the way to go about good business.
No, and that's right, and that's what the IPCC tries to do, is actually provide an informed perspective on all of these sorts of things that we talked about today, Bill.
Well, we've gone over the hour. I'd like to thank you very much for coming on. It was very informative, especially the overview of the IPCC process and the inputs. Going ahead, do you see yourself continuing in this role for some years to come, or do you looking for maybe a more relaxing period in your life? Because your timetable, your timetable is so incredibly difficult at times, from what I can see, and talking to a number of other people involved in this conversation. It's a wonder you get time for a cup of tea.
well, all of the IPCC stuff is voluntary, so it's on top of my day job. So, you know, and I actually got several day jobs because I've got lots of roles. So it's on top of all of those things, and so it is a challenge to juggle all the balls, but one I willingly take on. Any IPCC role is time bound, so my role as a vice chair will finish early next year when the next vice chairs get voted in, and so they, you know, there will be a new cohort of people coming into the IPCC at that time, and you know, with all, you know, due process surrounding that. So all of my past IPCC roles have all been time bound, and they're all independent. So for every one of them, you've got to be selected on merit for that role, and so, which is the way it should be as well. And so you know, who knows what's going to happen out into the future, but this current role finishes, I think it's in March of next year. In terms of the other people engaged in IPCC processes, it is a really demanding process. Like people get exhausted by it because it's just so intense, and it's intense because it's not just dealing with the normal science, you know, publication process. It's actually that interaction between the policymakers and the scientists really ramps up the pressure and ramps up the demand for the scientists who are engaged in this. And whilst that's demanding at the time, I actually think a lot of people who, once they've gone through the process and look backwards, they really appreciate the things that they've gained through engaging the IPCC and actually having some influence on the discussions that happen around climate change right around the world. Okay,
then we'll wind it up there. I'd like to again thank you very much. If you just stay on the air, I'll just introduce next week's show.
Okay, cheers, Bill.
Thank you. If you enjoyed the show, please like, subscribe and share on our Facebook page, and subscribe to our YouTube channel. Next week's interview will be with Vic Jurski. Now, Vic is a former forestry and science manager with the Department of New South Wales Forestry, and he'll be talking on koala, I won't say koala bears, it's koalas, in regards to the latest regulations in regards to land management to keep this species well and alive going into the future. So join me again next week.